Hello, we're going to be looking at the STEP question from assignment 23 of the STEP support programme. So this is a question all about some circles. It's got two parts. The first part is a general part about one circle, and the next part is actually trying to find a specific circle. The first part is basically about family circles. The last part is actually looking at one particular circle. So let's start by looking at just the first part. So here we've got the equation of a circle C. We've got the centre of the circle in terms of t. So the centre is at 2t, t, and the radius is equal to t. We want to show that C touches the line y equals 0. So if you imagine a pair of axes, you basically have three cases that can happen. So the line y equals 0, we also call the x-axis. You could have a circle which doesn't touch it at all. You can have a circle which crosses in two places, and then you could have a circle which just touches. So if it just touches, we only have one solution. Only have one place where y can equal 0. So that's what we're looking for. We're looking for that one solution when y equals 0. So if we take y equals 0 and substitute it in, I'll just try and find my pen back. So y equals 0 gives us x minus 2t squared plus 0 minus t squared equals t squared. This gives me x minus 2t squared. This thing here is the same as minus t all squared. And minus t all squared is the same as t squared. So x minus 2t squared is equal to 0, which gives me x equals 2t only. And it might actually be quite a good idea to try and sketch this out. So we have a circle. We know the centre is at 2t, t, which we're going to put here, 2t, t. The radius is t, and it intersects at this point when x equals 2t. So we have a circle, which hopefully is vaguely circular. That's not quite right, but you get the picture. You get a circle which has got a centre at 2t, and then just touches the x-axis at 2t. Okay, so that's the first part of the question done. So it's quite nice to just tick it off to show that we've done it. Let's have a look at the next part. Oops, that's supposed to be a select button. There we go. Okay, so for the next part, we're going to let alpha be the acute angle between the x-axis and the line that joins the origin to the centre. So that might be a good idea to draw that line in so that we know what we're talking about. So this is the line that joins the origin to the centre. And it keeps going on forever. And this angle is alpha. Okay, then it says show that 2 alpha equals 4/3. That should really be the whole thing there. Let's start by actually just thinking about what alpha is. So what I'm going to consider is I'm going to consider this right angle triangle, and I'll draw it out here to make it a bit clearer. So we have this right angle triangle, this is alpha, this distance here is 2t, because we're going along to the centre point, and this distance is t. And that tells us that tan alpha is equal to opposite over adjacent, t over 2t, which is a half. Okay. Tan of 2 alpha, so we know what tan alpha is. Tan of 2 alpha is the same as 2 tan alpha over 1 minus tan squared alpha. So that is 2 times a half over 1 minus a half squared, which is 1 over 1 minus a quarter, oops, which is the same as 1 over 3/4, multiply top and bottom by 4, that equals 4 over 3. So we've now done that part as well. So we know what tan of 2 alpha is. The very last part, we're asking to deduce that C touches this line. This line here, you'll notice, has got gradient 4/3. So there might be some connection with what we've just done here. So let's think a little bit about the actual drawing that we've got. We'll get rid of some of this working. If you consider this picture that I've got down at the bottom, and you consider reflecting in the in this red line that goes through the origin and through this point here. I'm trying to draw and I keep missing the button. If we reflect this in this line, we get another line up here, oops, which will also just touch, and this angle will also be alpha. So you can, if you like, talk about circle theorems, but basically by symmetry, that will be how you find the other line. So I'll just put by symmetry. So if you want to, you can draw on the other line that touches or the other tangent. You know that tangents are perpendicular to radii of circles. You've got some circles here where you've got the right angle in each one. It's got one shared side, which is the same. It's got the radius on each triangle, which is the same. By RHS property, these two triangles are congruent. Therefore, these two angles are the same, would be how you would formally prove that. But for this question, it'd be enough to draw the picture on and say by symmetry, this angle is alpha. So this line here, I'll draw it out here again. This is the other line that touches the angle. So it'd be quite nice to know what this gradient is. So the gradient here is equal to opposite over adjacent. So this line over this line, which is equal to tan of 2 alpha. So the gradient is 4/3. We've already worked it out. Therefore, C touches the line y equals 4/3 x, or if you prefer, 3y equals 4x. So now I've done that part as well. So that's everything done in the first question. It's a really good idea just to tick off the bits as you do them, because there are lots of things you've been asked to do in this question. So just to make sure you haven't missed one. Okay, so let's have a look at the second part of the question. And just a bit of warning, the algebra is about to get a bit messy. Now we want to find the equation of the incircle of the triangle formed by these 3 lines. And down here, it tells you what the incircle is. So basically, any triangle that you draw, you can always draw exactly one circle, which just touches all 3 sides. So that's what an incircle is, and it has explained it in the question. Thinking about what we've done in the first part of the question, we were looking at triangles which had a certain center. So we were looking at triangles which had a center at 2tt, and we showed that they touched the y-axis, and then they also touched this line with 3y equals 4x. Now, t can vary, and you might want to try doing this on GeoGebra and just playing about with t and seeing what happens. But t could be bigger, t could be over here, in which case you get sort of a bigger circle, but it still touches those 2 lines. Or t could be somewhere between these 2 points, and you get another one. But basically, any circle which has the equation of the form in the first part of the question will touch those 2 lines. But the question now is which of them also touches this line. And once you've got this 3rd line in, you fix in your circle to 1 point. So that's what's going on in this question. So let's think about actually trying to show it. So I'll try and draw a slightly neater picture now. We've got the lines x-axis, which is y equals 0, y. We've got the line 3y equals 4x. And then we've also got the line 4y plus 3x equals 15. That can be arranged to get y equals 1/4 15 minus 3x. So it's got a gradient of minus 3/4. It crosses the x-axis at 5. So when y equals 0, x equals 5. When x equals 0, y equals 15/4. So we're looking for, if I can draw that a bit better, we're looking for a circle that just touches all these things. My circle is a bit more of a squircle, it's a bit squared, but that's the sort of thing we're looking for. And again, you might like to draw this out in GeoGebra and actually see what it looks like. So from the first part of the question, we know that this equation touches the y-axis, sorry, not y-axis, y equals 0 line and the 3y equals 4x line. So the only question now is, where does it touch the last line? So I'll write down the equation of the last line. So what we want is we want one solution. So if they touch, you get a repeated solution or one solution because it's a quadratic. We want one solution of that pair of simultaneous equations. We only want this circle to meet the other line at one point, which is going to be this point here. One point of intersection. Okay, so this is some simultaneous equations. We can solve them. I'm going to start by expanding out one. X squared minus 4xt plus 4t squared plus y squared minus 2yt plus t squared equals t squared. And those cancel out. So that's expanding the first one. Now what I'm going to do is I'm going to substitute for y, and I've got y written in terms of x up here, so that's quite useful. X squared minus 4xt plus 4t squared plus 1/16, because I'm squaring the quarter. 15 minus 3x, let's just hold that for a second. And then I've got minus 2t. So I'm looking at this part now. 2t times y, so 2t over 4 for the quarter. 15 minus 3x brackets equals 0. So I've substituted for y. Okay, I don't like this 16th, so I don't like fractions as far as if I can help it. So I'm going to multiply everything by 16. 4 times 16 is 64. 4 times 16 is still 64. This we've multiplied by 16, so we now can get rid of those. And then 2t over 4 times 16. So I've got 2t over 4 times 16. I can divide top and bottom by 4, and I now get 8t. So this is 8t, 15 minus 3x equals 0. And then I can do a bit more expanding. 16x squared minus 64xt plus 64t squared plus 15 squared is 225. 15 times 3 is 45, doubled is 90. 3x squared, negative 3x squared is 9x squared. 8 times 15 is 120. And then 8t times 3x, that is 24t. Sorry, tx. So quick check just to make sure I have done this all correct. There's no t there, so that all looks okay. And then this is a quadratic equation in x. Let's just tidy it up a bit. We've got 25x squared. In terms of the x values, we've got minus 64xt plus 24tx. So that's mine, and we've also got a minus 90x. So that's minus 90 plus 40, because it's a minus 40 tx. So that's that term, and this term. So those are all my x terms. And then the last term, I've got 64t squared minus 120t plus 225 equals 0. Okay, so this is a quadratic equation. We want the quadratic equation to only have one solution. So what we actually want is we want the discriminant to be equal to 0. So let's just get rid of these bits. So we want b squared minus 4ac equals 0. Or if you prefer, b squared equals 4ac. So let's look at this thing. So b squared, that is this thing here. So 90 plus 40t all squared is equal to 4 times 25 x squared times c, which is this thing over here, 64t squared minus 120t plus 225. That's using b squared minus 4ac equals 0. Okay, this looks slightly horrible at the moment, but it's actually going to get quite a lot nicer very, very soon. Here we've got a factor of 10. So I can take out a factor of 10, but remembering that this is a squared bracket, so that's 10 squared. So I'll get 10 squared, 9 plus 4t all squared. 4 times 25 is 100. So that's actually now quite nice because I can divide both sides by 100. Right. My situation has now improved slightly because I don't have all of those big numbers to deal with. Okay, so let's try doing the next bit. This is 81. 4 times 9 is 36, but we need to double it. So 72t plus, 4t, that's 16t squared, is equal to 64t squared minus 120t plus 225. Okay, it feels like we're now on the home straight. 64 minus 16, that's 48t squared. Minus 120 minus 72 is minus 192t. And then 225 minus 81 is, 225 minus 80 is 140. And then we get 144. Okay. I think I can actually do some dividing here. I think all of these are divisible by 12. So if I divide by 12, they're probably divisible by something a bit bigger, but let's divide by 12 first. 48 divided by 12 is 4. 192 divided by 12. Well, I know that 180 divided by 12 is 15, so this makes 16. And 144 divided by 12 is 12. Okay, now I can divide by 4. So I'm going to get t squared minus 4t plus 3 equals 0. Okay. Then this gives me t minus 3, t minus 1 equals 0. So we seem to have got two values of t. So let's not panic to begin with. We've got t equals 3 and t equals 1. This would give me the center of the circle is either at 3, not 3. So if t equals 1, the center is at 2, 1. If t equals 3, then the center is at 2tt is at 6, 3. So going back to our picture over here, this circle here with a center at 6, 3 is actually one with a center all the way over here-ish. And it's a bit hard to see because I've got all this stuff in the way, but I will delete this in a second. But there's another circle over here. This one here is our one with our center at 2, 1. So I'll try and draw you a big picture to show you everything that's happening here. But basically these two values of t here are corresponding to either side of that line. And we want the one that actually lies inside of those three triangles. So let's just delete all that, try and draw a much better picture. So this is our y-axis. This is our x-axis. This is 3y equals 4x. And this is our 4y plus 3x equals 15. This is our 15 over 4. This is our 5. So we have one circle here, which is vaguely circular, which has got 2, 1 as its coordinates. And then the other one, something like a center about here-ish. And basically it sort of just touches here, here, and here. That wasn't a very good circle. Again, do it on GeoGebra. But that is the situation that's going on. So we want the incircle of the triangle. So we want this one here. So this is when t equals 1. So the equation is x. So don't forget to the last bit, which is find the equation. x minus 2 squared plus y minus 1 squared equals 1. And that's the final answer. So go and have a play on GeoGebra or on Desmos and see what happens with these equations. And thank you very much.